Good day class. Today we are talking of projectile motion. Projectile motion refers to the motion of the body projected at an angle in air. For example, if you throw a javelin into space, projectile motion goes like this. If you throw a baseball into space, throw it like this, it goes like this. An object into the air at an angle and into the air, it goes like this. Let me give you a diagram so you understand better. This is projectile motion. Something like this. At an angle, theta. If you throw a baseball, it goes like this. To go up to a certain height, h. This is certain height, h. This is called the maximum height. It goes up to the maximum height. Then before it drops down. Yeah. So this is example of the projectile motion. Now these are the formulas we use in solving the projectile motion question. Number one, we have the t equals to u sine theta over g, where u is the initial velocity, theta is the angle, and g is the gravity. Number two, we have the capital T. This capital T stands for period. This one is time. This one is period. Now we have u, which is set to the initial velocity, theta, and angle, and g, gravity. We also have h. This h stands for the maximum height attained. When this is the height. You know, if you throw something up, it will get to a height first before it starts dropping down. That is gravity. To get to a height first, depending on the force you use to throw it. You throw it up, it will get to a height first before it will now drop down. So that height it gets to is h, capital H. That is the maximum height attained. And we have the sine squared theta over 2g. We have the range. Range is known as the horizontal distance. So this is the range. Arrow. The horizontal distance, as it goes like this, the maximum height goes down. From here to here, this is the horizontal distance, known as the range. And the formula for the range is u squared sine 2 theta over g. Now let's go over to solving questions. Then come to this physics tutorial. Today we are talking of oblique projectile motion. What the previous video? The previous video was on parabolic projectile motion, where you throw the body from an angle, it reaches the maximum height, and it falls back to another angle. This is parabolic projectile motion both. Today we are talking of oblique projectile motion. In oblique projectile motion, you don't throw a body from an angle, you throw it at a height, like from a point, you throw it straight like this, and it falls back. Unlike parabolic, you throw it like this. It goes like this. But in oblique, it's going like this. Throw it straight. As you can see from the diagram here, the body, example, you throw the ball straight, it goes up to the maximum height. This is the maximum height range, and it falls back. The horizontal distance is known as the range. From the previous video, yes, the horizontal distance is known as the range. Now, this is the formula. The formula for oblique and parabolic, they have two different formulas. For oblique now, the formula for range, arrow, is initial velocity times period. T stands for period. The formula for period is square root of 2 times your height over the gravity. While the formula for your height is gt squared over 2. Using your common sense, you can also say that range now, arrow, equals to initial velocity times, instead of this t, we know that this t is this. So we can now put this like this. This is also range. Any higher is the same thing. Either this or this, because period is this. So we replace this t with this guy. So that is oblique. Now, let's do an example. We have an example here. The example says a missile was projected to hit the target 500 meters away. Calculate the angle of projection if the initial velocity was 100 meters per second. In solving, the first thing to do is to apply your parameters. I've always been saying to all my videos, they apply your parameters first. So let's go. Our given. What do we have? We have that the missile was projected to hit the target 500 meters away. If the target was 500 meters away, what does that mean? The horizontal distance. The target is 500 meters away. So meaning your range now arrow equals to 500 meters. In physics, you need to understand these basic terms. They said 500 meters away. Because they said 500 meters above, it means what? Height, sharp. 500 meters above means height. But 500 meters away means the horizontal distance, which is what? Your range. So our range is what? 500 meter. And we have that the angle of projection. So we calculate the angle of projection, meaning we calculate our theta. Theta equals to what? Unknown. We are getting our parameters. If the initial velocity was 100 meters per second, if you watch the previous video, the initial velocity was given by the symbol u. So u equals to 100 meters per second. So now we have this parabolic projectile motion. So a parabolic, the formula for range, R, just cancel digital. So we have our given, which is this. Now we now think, what is the best formula? No, this is parabolic projectile motion because they said the missile was projected. In case they said it was thrown like up at a height, you know it's oblique because oblique there's no projection, it's at angle 90. But they said it was projected to meet the target, meaning it's parabolic, it goes like this. This is the diagram. You can tell the diagram that's small one, so let's just draw it. Take the diagram is something like this. Parabolic projectile motion like this. Where this is your maximum height. This is your horizontal distance, R, your range. And this is your angle, what are you looking for? Theta. For this angle. Okay, so now, and this is the initial velocity u, which is 100 meters. And this is your initial velocity u, which is 100 meters per second. Now, who is the formula for range in parabolic projectile motion? Is in the previous video. Formula for range is R equals to u square sine 2 theta over g. This is your formula for range. Do we have u? Yes, we have u. Do we have our theta? No, we don't have our theta. Do we have range? Yes, we have range. But do we have g? Yes, we have g. G is a constant, so stands for gravity, and gravity G equals to 9.8 meters per second squared. Now, we have range, we have u, we have theta, we have G. 1, 2, 3, 4. But we're looking for theta, so we have to make theta select the formula. Have we? Yes. And let's try and make theta select the formula here. Let's multiply first. Because multiply, we have this arrow G. Gravity times the range equals to, arrow G equals to u squared sine 2 theta. We have this. We still need to make theta set the formula. So now let's take this u squared here. So we have sine 2 theta equals to arrow G over u squared. We have sine 2 theta, we have sine 2 theta. But we need to remove this sign from here, this is here. What are we going to do? We use arc sign. So, taking arc sign on both sides, we have that arc sign is equal to sine inverse. So, if you take arc sign on both sides, we have that 2 theta. This sign will cancel equals to sine inverse of what? Arrow G over u squared. So, what I did, there is sign there, but we're trying to make theta straight to the formula. So we took this sign to this other side. How do you do it? We use sine inverse. We use sine inverse. Sine inverse will cancel this sign here. And sine inverse will be here. So that is 2 theta sine inverse of arrow G over u squared. But there's still 2 here. Let's take this 2 to the other side to finalize it. So now meaning theta equals to sine inverse of arrow G all over 2u squared. So now this is our theta. Now let's input our parameters. So meaning theta now equals to sine inverse of, what is our arrow? 500 times, what is our G? 9.8 all over 2 times, what is our U? 100 squared. So theta equals to, if you want this calculator to get your final answer, I'm not going to calculate it again, but you're putting an answer. Just punch all these values, you punch it to get your final answer. Thank you. But let me go over again. The question said the missile was projected to hit the target. What does that mean? It was projected, meaning it was projected at an angle. So it's parabolic projectile motion. They said it will hit the target 500 meters away. The target was 500 meters away. That is the horizontal distance range. So our range is 100 meters. Calculate the angle of projection, which is this angle theta. If the initial velocity was 100, meaning the velocity of the missile, like the velocity is going, the initial velocity is 100, that is u, equals to 100 meters per second. We have our parameters here, alpha 500 theta or mu, what we're looking for, u 100 meters per second. Now remember, for range, if you want for range in parabolic projectile motion is r equals to mu squared sine theta over g. We have r, we have u, we have theta, we have g. But sorry, we have r, we have u, we have g, we're looking for theta. So we made theta solve the formula. We took it to this side first, r g equals to u squared sine 2 theta. After that, we took u squared to this side. That is sine 2 theta equals to r g over u squared. But there is sign here. We're making theta solve the formula. So we found sine inverse of both sides. This sine will not cancel out. Sine will cancel out. So we have 2 theta. If sine cancels out, what's the remaining is 2 theta equals to sine inverse of rho g over u squared. But I still 2 here. We take 2 to the side. That is theta equals to sine inverse of rho g over 2 u squared. Now if we put our values, then once you calculate it, you get your final answer.